It's a great pleasure indeed to be here. Thank you very much for the invitation. So I have a case study on industrial economics about the link between exporting activity and productivity of firms. But first of all, I would like to make some remarks about the state of the art of the application of automatic causal search to economics. 20 years have gone by since the publication of the book Causation, Prediction and Search by Peter, Clark and Richard, and 13 years after the second edition of this book and the publication of Causality by Judea Pearl. So my personal consideration, it's a personal consideration, is that causal model search is actually a fairly known approach among econometricians, especially among young researchers and PhD students. I mean, among people interested in causality issues in economics. But there are not so many applications. So let me substantiate a little bit this remark, and I checked a database, a bibliographic database, the Scopus database, and looked at published articles in economics, econometrics and finance between 21 and now. I mean, this is not a rigorous bibliometric exercise. But still, looking at, I searched the words causal, causality, and causation in title, abstract, and keywords, and we have like 4,193 articles in which they have this word, about 5% of all articles in economics. I mean, not all the articles in this database, but the most of the journal are present in this database. So the same words with Peter Sperter, so Judea Pearl in the reference, 84 reference. Granger in the reference, 1,450. I mean, Granger developed this approach since the 69. He got a Nobel Prize in economics. It's a different situation. Let's look, for example, Engrist and Pischke and Imbens, the advocate of the instrumental variable approach in economics, got 338 citation. Heckman, another Nobel Prize actually in economics, 277. Holland and Rubin, 193. So I would say there are not so many applications. I mean, this number is not so small. I mean, if we consider that we are comparing with the Nobel Prize in economics, but still, although there are, I mean, I think my personal feeling is that people know about this approach. There are not so many applications in economics. That's my personal feeling and the situation as it appears from this small exercise. So one field of econometrics where causal model search brings a clear contribution, in my opinion, is structural VAR. Structural VAR econometrics, especially as applied to macroeconomics, and Kevin Hoover gave a talk on this issue. And I see here really an advantage of the use of graphical causal models to identify the causal structure of behind the data. And here I see a clear advantage with respect, for example, to Granger causality. I mean, it is a little bit alternative because Granger causality looks at the reduced form models, while the graphical the structural model. I should add here that Granger himself actually wrote an article in 1997 actually was one of the first time to apply the graphical causal model approach to this problem. So it's not related to Granger, but I see here an advantage with respect to the Granger causality approach. There are less applications to microeconomics, especially to microeconomic panel data. Here the natural experiment approach is the standard. We see many applications of the instrumental variables and the potential outcome matching methods. I mean, not that these methods should be considered as as opposite to the graphical model approach or to the causal model search, but we don't see integration between these methods and the search methods as developed by Peter, Clark, and Richard, and the Judea-Perles method. So let's go now to the case study I have and see also if we can learn something about the case study, also to understand the situation of the applications of these methods to economics. This is a joint work with Tommaso Charli and Alex Code for University of Sussex. It's a working paper, so it's not a finished paper, and actually we have preliminary results. So there are still things we want to do, but I think it's useful because I can show you what are also the difficulties or some of the difficulties, and some of the gains also of this approach. So here we want to focus on the research question is about the causal relation between engagement in international trade and firm performance. The question is which direction goes, if we have a causal relation in this link, in which direction goes, if this relation is causal at all, and whether it goes in both directions or we have a more complicated relationships, for example, involving other variables. So settling such a question brings a contribution to the understanding of the cause and consequences of international trade. I mean, these questions are usually treated in terms of comparative advantage, increasing return to scale, consumer love for variety, where we treat countries as representative firms. So this is an old literature going on since the 19th century. And in the recent decades, there is an increasing literature that looks at the nature of exporting firms. So it doesn't look at countries treated as representative firms, but try to look at the characteristics of the firms that are involved in exporting activities, and we try to give a contribution to this literature. So there is an established stylized fact about the nature of these firms. Trading firms are different from non-trading firms, so there are studies pointing out that trading firms that engage in exporting are different in terms of size, productivity, skill and capital intensity, wages. And this stylized fact, is robust across a variety of countries, industries. And actually the difference between exporting firms and non-exporting firms, it sounds like a paradox, but exists even before the exporting begins. Even when the firms are not yet engaged in exporting, are different from firms that then eventually will not be engaged in trade, in exporting. So the question here is, are exporting firms more productive because of exporting, or because only the most productive firms are able to enter the export market? So the literature has found explanation that goes in both directions, saying that only very productive firms engage in trade because of their cost, and on the other hand, when the firms are engaged in the exporting, they learn and they become more productive. So there is a mixed evidence about that, and the typical approach in this, to address this issue, like many other issues in microeconomics, is the use of instrumental variables. For example, this researcher Thorsten Hansen use an instrument and to find out use an instrument about use tariffs to find out the possible causal relationship going on between the exporting activity and productivity. And then there are studies using matching methods. So we are trying to use causal search methods. First of all, about the data, before talking about the method used. The focus here, our data, is about Chilean firms, actually Chilean plants, and we try to find out the interaction of exporting productivity of Chilean plants in the years between 21 and 2026. So we use a survey of manufacturing plants. Our data comes from this survey of manufacturing plants collected by the Chilean Statistical Institutes, where we have actually plants with more than 10 employees, more than 6 months activity, and classified in different manufacturing sectors, and exporting, so firms that are active in exporting in the years between 21 and 26. Our measured We are interested in the size of these plants, which is the size proxy by the employment, so the number of the employees, the output, so proxied is the proxied by the total sales, which we have divided here between domestic sales, also what they sell in Chile, and export, what they sell abroad. And then we have productivity estimated by total factor productivity. So productivity is not a variable that we observe as easily as sales, but it's something that we have to estimate through a regression. So total factor productivity is the factor that have effects on total output that are different, that goes beyond the effects of typical input as labor and capital. So it's a residuum of a regression of output on labor and capital. So it's something which is estimated. So there are indeed several measurement issues here. I'm lucky that I have good co-authors that are very expert in this field, in industrial economics, that are able to deal with these issues. But of course, there are a lot of decisions to be taken. For example, our data are about plants, not actually firms. And in the case of more than 50 employees, we have plants that actually belong to the same firm, which measure firm performance, why we should use total factor productivity, and how do you measure total factor productivity. I'm not going to the details of the decision we took here, but just to give you a feeling that we have a lot of decision to take, and this decision, of course, may have a different result on the causal question we are facing. For the problem of the deflators, because we have to deflate not only sales but also the capital to measure total factor productivity, the treatment of outliers. Whether we take the data in levels or in difference, we decide to take in differences. Actually, we decide to use growth rates to overcome the problem of stationarity. But so for every decision there is a justification, but of course this justification can always be discussed. So these are our variables that you use in our exercise. So we have the growth rates. So we took the difference in logs of domestic sales, of employment, exports, and total factor productivity. Our sample size is 4,021 observations, and we have 1,309 plants and 5 time periods. Not for all firms, not for all plants, I should say, sorry, because the panel is not balanced. We have for some plants, we don't have observation for time periods because evidently some plants were not engaged in exporting activity for years. There are some plants which were engaged in exporting activity just for a couple of years, for example. So we estimate, our strategy is to estimate a pooled panel vector autoregressive model. And on the basis of estimated residual, we search for the underlying structure of VAR. So here, apart from the fact that the data are completely different, here the method is exactly the same of the method Kevin Hoover presented in the previous session. The idea of looking for the structure VAR using an estimated VAR. Maybe also the interpretation is a little bit different because I start here saying we have a latent data generating process. So this is the structure of VAR. We have here the contemporaneous causal relationship. So in our case, the vector of our variables is growth in domestic sales, growth in employment, growth in export, and growth in total factor productivity. So here I'm going quite fast because I think we learned already what VAR is. I mean, we cannot estimate, I mean, equation 1 and equation 2 are equivalent. So it's the structural model, which is latent and describes the structural relation, so the data generating process underlying the data. We cannot estimate it directly because we have problems of endogeneity. We don't know. We may risk to regress an effect on its cause. So we don't know what are the coefficients of this matrix B. What we can estimate is a rotation of this model, is the reduced form vector autoregression. It is the standard literature on VAR. We can estimate this, but this is insufficient for causal knowledge. I mean, insufficient to get the structure VAR. We have less parameters in equation 3 than in equation 2. Okay, there are more parameters here. Oops, sorry. Then here. Okay. So to identify the structure VAR, it is crucial and sufficient to find the correct gamma naught which produce the right transformation of the residuals, of the estimated residuals. And the gamma naught incorporates information about the contemporaneous causal relation among the variables. How to find gamma naught? Postal model, and indeed David Bessler, Kevin Hoover, and also myself gave contribution to identify this matrix on the base of the partial correlations of the estimated residuals. The underlying assumption is if you use partial correlations, because graphical causal models don't say that you have to use partial correlation. You use conditional independence test. But if you use partial correlations, the underlying assumption is Gaussianity. So I ran this PC algorithm using actually an R package. And I get this. Of course, it's based on some conditional independence test. The conditional independence test here is the partial zero is test on zero partial correlation, and zero partial correlation test based on the Fisher Z transformation. And it comes out that only one conditional dependence was not rejected at the 0.01 significance levels. So actually, if we change the significance level of use another lag, actually we have this structure. So we don't find zero partial correlation changing the significance level of the lag. But, so, I mean, graphical causal model is a constraint-based causal search, and is based, I mean, it has to be based on conditional independence tests that are adequate with respect of the probability distribution. So Fisher Z transformation test require Gaussian data. We can use other tests like the wall test on the VAR residuals, but this also requires an asymptotic Gaussian distribution. Are the data Gaussian? No, they are not. Here in this case, they are not. I mean, here I show the histogram of our data. This is an estimated normal distribution using the empirical mean and empirical standard deviation of our data, and we see that our data are much more peaked. They have like kurtosis, and they look very non-Gaussian. We have kind of fat tails and kurtosis. And also from the cuckoo plots, we see that the data are not Gaussian, and if we don't believe this graph, we can run the typical test of Gaussianity, and which strongly reject the null hypothesis of normality. So what can we do? Well, we can, for example, test in condition dependence, taking into account non-Gaussianity. I think we can, for example, use a non-parametric test of condition dependence, which work very bad when we have a lot of conditioned variables. But in our case, we have just 4 variables. So it would be just to test whether 2 variables are conditioned on 0 variable, 1 variable, and 2 variables. They may work. So in this case, I have done some simulation about this test, and actually they work until 2 conditioned variables. I have tried it. I'm not showing any graph, but there is not much conditional independence here. We couldn't find any conditional independence with this data. I mean, as you also can guess only from the partial correlation test, we don't find much conditional independence. So our idea, the route that we take, is to apply the LINGAM algorithm, the VAR-LINGAM algorithm, as developed by Shimizu, Hoyer, Hiverin, and Kerminen. And then the LINGAM algorithm, then applied to the VAR by Hiverin and Shimizu and Hoyer in 2008. And they have already applied this method with some co-authors, Doris Entner, Patrick Hoyer, and Alex Code, in a paper published this year in the Oxford Bulletin of Economic Statistics, to macroeconomic and also microeconomic data. So we have applied now this algorithm again. The conditions, the assumption on which this application can be made is non-Gaussianity. So we assume that the structural shocks are non-normally distributed, that they are independent. These are not big assumptions to do that. Well, we'll talk about later whether this assumption is strong or not. I have to say something about it. But anyway, it's typical, let's say, in this way. It's a typical assumption in the structural VAR literature to assume that the shocks affect the system in an independent way, I mean independent cross-sectionally and also across time. The shocks that we don't see, and the acyclicity, that the contemporaneous causal structure among the variable is acyclic. These are the assumptions on which this algorithm works. I mean, let me be very fast here. The idea, I mean, because we have also people here who have developed some part of the algorithm, I mean, some extensions of this algorithm. So I think a lot of you are also aware of this VAR-LINGAM algorithm. So, I mean, the idea is to estimate the VR model in a classical way, like an OLS regression, check whether the residual are non-Gaussian, then use FASTICA, so you consider these independent shocks that you don't see, so the latent independent shocks as independent components, and you try to reach information. So you see the estimated residual as a mixture of these independent shocks, which are latent. And the ICA algorithm, the independent component analysis, is able to recover this mixture matrix, the matrix P, which mixture the independent shocks. So you find this matrix, and you call the gamma naught the inverse of this matrix, but there is something which remains undeterminate in this algorithm, is the order of the shocks, and actually also the size of these shocks. So you do. So the idea, the authors that developed this algorithm, that you do other steps first to find the right permutation of this matrix. So you want to have a matrix, a permutation of this matrix which have a non-zero on the main diagonal, because in order to find what is the correct order of this algorithm, and you know by assumption that this gamma naught has no zero on the diagonal. And then you want to find the causal, the causal structure. So you first normalize the diagonal of this matrix. You normalize to 1, and then you find the right permutation of this beta matrix, which incorporate the contemporaneous causal relation, in order to have this matrix as close as possible to strictly lower triangular. And we have some tested ways to find this lower triangular matrix. And you set the upper triangular elements to 0 and permute back to obtain beta hat, which now contains the acyclic contemporaneous structure. And then you calculate the lagged effect. So you can basically, to put it shortly, you recover, so you assume that you have independent shocks affecting the system. And what you estimate is a mixture of these shocks, and you can recover the way by which these shocks have been mixed using this approach. 5 minutes, so I have to hurry up. So, look, this is the result of the LINGAM. One lag, because that was what lag selection told us, that there is one lag. Well, this is also another story. We can try different lags, but at least these criteria suggest us that there is one lag, and is more appropriate here to use a least absolute deviation than OLS. Because in case of fat tails distribution, like Laplace distribution, the maximum likelihood estimator is not OLS, but is LAD. So, these are the numbers that we get. These are standard errors obtained through Bootstrap. And also you get here, what you get here is the contemporaneous matrix of the structure, the matrix of the contemporaneous effect, and the matrix of the lagged effect. So we have in this application we have this where employment is driving all the other variables. Then we have productivity, so it's like a Cholesky order, right? The first one is driving everything, then we have productivity, then we have exporting, and then domestic sales. So we were interested on the relationship, most of all, between productivity and exporting. In this case, we have, so in this first shot application, we have that productivity is actually causing export in the simultaneous structure and not the other way around. But let's see. So this is another way to write the same thing, right? So employment is driving everything, then productivity, export, and then domestic sales. This is a positive effect. The blue one and the red one are negative effect. Lagged effect, so I think that when you find the contemporaneous causal structure, then you can rotate also the estimated lagged matrix, the matrix of the lagged effect, and this is what you find also here. For example, we are much interested between the relationship between productivity and export. So we see that productivity is causing export within the period, so within 1 year. But export is causing productivity in the next year. So we display the lagged effect only, so we display only the lagged effect that are significant at the 0.05 significance level. Okay, so first description of this preliminary result. So the the first driver here is employment growth that directly affect domestic sales and export. So employment growth has a negative effect on the productivity growth. So like downsizing firms, one interpretation of this is better able to provide productivity than investing firms. So the important result, as I mentioned, is export growth. Actually, no, that the total factor productivity growth, so productivity growth, have positive impacts on export. So like firm better off when they put total factor productivity. No, let me express it better. So yes, so, I mean, it's basically productivity and export. So if yes, I mean exactly. This is productivity. So has an impact. The total factor productivity growth has a positive impact on growth of domestic sales and export. So it's not the other way around within the period. So within the period we have this, but on the other periods, if we consider lagged effect, exporting growth has a positive impact on total factor productivity growth. But it's interesting to look at the size of these numbers. I mean, we should always, this is the size of the effect of total factor productivity on export within the period. And this is the standard deviation of this impact. And this is the size of this is the coefficient which express the lagged effect of export on the total factor productivity. And we see this as a smaller size, considering also the standard deviation is a smaller size. I mean, I would not put too much emphasis on this significant or not significant coefficient. There is an effect here also, which has a small size from total factor productivity to export. But let's go back here. So I think the first thing we want to check how stable are this link. And I completely agree with Kevin's idea of using bootstrapping. So check the robustness of a causal structure to a bootstrap procedure, and we find this interesting thing. I mean, it's not surprising for an economist that export has an effect, a negative effect on domestic sales. So you focus on export, so you neglect domestic sales. And the other way around, if you focus on domestic sales, you neglect export. So it's almost a chance that we observed in the one-shot output of the algorithm, the direction going in this way. If we see that at bootstrap, almost half of the time we get also the other direction. It could be a sign of feedback. We should check with the Lacerda and Coulthard's algorithm. So what is important to check? I mean, so my recommendation is to check across bootstrap samples as we have done, but also to make a lot of other controls that some of them we have already done, some of them we still have to do, and the question is how to do in a rigorous way in order to avoid like data mining biases. The first one thing that we should control is to control for dummies. We have checked for time dummies, and actually we don't get different results. But we should check, for example, for sector dummies. That's one thing I would like to do. We have different measures of productivity. There is a literature what is the right measure of productivity, and to see whether the results are robust across different specifications of the productivity, sectors, size, to check whether there are different effects between the big plants and small plants, old exporter and the new export, old exporters and new export. So far we have a stability of this. So far, I mean, as far as I have seen, We have not done all of these, but some of them, we have found some stability of this link and the absence of the other link and a weak but stable link in this way. Sorry?
Is that the same?
So yes, sorry. Export, no. Export, yes, total factor productivity, stability of this link, absence of, sorry, it's the other way around. Yes, wrong. Absence of the link from export to total, so it has to be in this way, direction. So. And a weak stable link from export time t to total factor productivity time t. So yes, here should be the head of the arrow, here. And then, I mean, another thing we should do is the studying the effect of net intervention to inputs response function, as Kevin was suggesting. So let me go, what can we learn from causal search method? So the gains, in my experience, the application of these methods is the emphasis on the structural model. So it's really a gain to see, okay, let's try to go beyond the reduced form model. So, and on the basis of the adequate characterization of the joint distribution of the observed variable, it allows to select the possible causal structure. Another gain is that the automatic feature of these methods help perform a rigorous robustness analysis. The question isn't only how to perform it, but I think it helps a lot to perform it. Pitfalls. So of course, the pitfalls are exactly this. I mean, there is a possible sensitivity of the result to the fact that we can measure the variables in different ways. We can use different controls, different rescaling, and there is a possibility of data mining or publication bias. Heterogeneity, I mean, when we deal with firms, heterogeneity across individuals and over time. Feedback and latent variable, we have said this already. I mean, I think we can identify feedback possibly with the bootstrap procedure or through the Lacerda and Court's algorithm. But the question is how to distinguish between a feedback and a latent variable. A drawback of the VAR analysis, in my opinion, is that the number of shocks is exactly equal to the number of equations. We can, it can be in some situations, especially if we consider the situation of several firms, that we have a different number of independent components. So the challenge is exactly to address this pitfall. This is my last slide, okay? This is my last slide. So to integrate causal search methods with panel data analysis, allowing cross-individual heterogeneity. I don't know exactly how to do it, but this is for sure one thing we should work on. The integration with instrumental variable estimation, because instrumental variable is the typical tool to address this question, microeconomics. So I'm happy to have heard that Kevin is working on this, and I've seen a title on this issue because I see really a possibility of using graphical causal model to understand, to select for the instrument and to understand whether an instrument is good or not. There are several potentiality of graphical causal model to work on that. And then allowing for common shocks is just using a different econometric model, for example, a factor model, which you allow for common shock. And then I think, this is my last point, concerning the sensitivity of the possible sensitivity of the result to different measurement and different, and different controls. We should think, and I will do in the next period. I would like to think of methods that are able to analyze the results coming from alternative specification and find out whether there is a bias or not in the in the use of alternative specification. Thank you very much. That's it. I take your question.
Time for maybe one or two questions.
Yes.
I'm a little disturbed by, in both of these last talks,
by our treatment of these contemporaneous relations
Yes.
that assumes they are representative of causal relations, when in some cases I'm quite sure on a priori basis that they represent something else, a constraint that ties two variables, an equilibrium condition, where the actual causality can only be sensibly understood as these are simultaneous outcomes linked in some way. For example, when you decide what your domestic sales are going to be and what your employment is going to be, you make that decision at the very same moment, I think, having taken into account a bunch of previous market information. So is there something I need to read, something I need to see that'll make me stop worrying about this, or is there really conceptual slipperiness that's
Maybe some scotch.
No, I mean it's an issue. I mean the link, the link, the not directed link that we saw between domestic sales and exports is difficult to be interpreted as a causal relation. But I think this method can suggest, I mean, these kind of things. I mean, indeed, I would not, I mean, since the bootstrap is showing that we have a link which is not directed, this could be interpreted as a non-causal link. Can be interpreted just, a mutual causality or just an equilibrium condition that we have between. But it's a little bit. I mean, I don't have precise answer to that. But it's a little bit difficult to say whether an equilibrium condition is a causal relation or not. It is in some sense. In other sense, not. So I don't have. Other things?
Yes.
Okay. I have a priori reasons to believe, I think we all do, that causal search methods work at some level.
Yeah.
But if they were failing horribly at your application,
Yes.
are there ways we would know?
For instance.
I am tempted to answer to apply, but that's very dangerous. To apply, I mean, with policy intervention, that's very dangerous. No, that's the reason they have to be used carefully through a good statistical analysis of the underlying statistical model and a good use also of the background knowledge. I mean, that's also a very difficult question. But I mean, the key issue I think here is, I mean, to show whether the results are stable across different situations. But yes, you may be wrong if I don't know.
Yes.
To comment on this, like, if it's stable, it doesn't mean it's right? If we do plain regression, it can be very stable, but completely non-causal. So if it's unstable, it's certainly not good.
They're always fallible. I mean, it's you can get wrong and you can get stably wrong. Yes, but I mean, yes, of course. No, the only answer is background knowledge. I mean, of course, if it's something. If something is completely at odds with the background knowledge, can of course also mean that the background knowledge is completely wrong. It could also be the case. I don't have a definite answer. The only way is to check how they works with simulated data. If you don't want to make experiment with the real, Sorry?
We need to do an experiment or experiments.
Yes. No, I mean if the experiments are dangerous. I mean, if we
More fun.
But sometimes we do policy interventions, right, in economics. So can't you take data before an intervention is done, predict it, and then see if it works?
Yeah, that was my question. Aren't there natural experiments in economic policy?
Yes, I mean this is indeed when I say we need the integration with methods that deal with the natural experiments. I mean,
There's another answer.
yes.
Which is that the causal structure suggests that certain interventions will propagate in particular kinds of ways. So if there's a structural change which is localized in a particular kind of way, if you've got the causal structure right, you will be able to predict what other things will break down and what things will remain invariant to that. So that provides a test. So it's not just a question of, oh, is it stable? It's a question of, is it unstable in the right sort of way or the wrong sort of way?
Yeah, this is not unique to
Yeah.
any sort of causal analysis.
No, I think that's an important point, is that there's a whole other tradition of causal inference that didn't come out of this tradition about looking at those kinds of stability relationships. And those two things can be merged.
Yes, exactly, yes. I mean, the integration with the other tradition is an important point, yeah.
Yeah, the question relates to your meta-analysis. I think it's probably, we're talking about causal model or whatever statistical model. Basically, at the very beginning, you already assume that it's sort of like a closed model in the sense that we consider all this kind of like the variables that already contained, right? But I think most likely all this, especially for social systems, it's not the depth of this kind of like the causal model, statistical model. How we choose the lack of the integrating into the openness of other factors into the model. So what do you think about this kind of thing? So I think like for the model, whatever model we use, it's sort of like if we stick with this model, it's a closed model already at that time because we close the boundary. But most likely, I mean, it's actually, in the reality, it's not just this kind of variables, but I'm talking about other possible variables.
So we are omitting, yes, in this case we were omitting these variables that play a role in this causal structure.
Yeah, because that's probably it's more dangerous to me.
No, the danger is to omit such variables in order to create a bias, because if you want to get this causal relation, I mean, you can play enough with the data. I mean, it's not always the case. I don't want to exaggerate, but here you have a lot of things to play with. You change productivity, you change it, and omitting. I mean, in this model you can take into account a bunch of controls. Okay. And also another question, whether you put the controls as exogenous variable or you enlarge the vector on which you want to regress. That's also another. So your question is, well, yes, a meta-analysis would help.
Yeah, probably will help.
Would help to see whether there are omitted variable bias. It would help. I think. I mean, something which I don't know much, but I think it's a possible. I would like to learn something more because it's a possible direction. When you have a lot of
possibilities are all different kind of like possibilities. Yeah. How do you compare?
Yeah, how do you compare? Yeah.
That's
Okay.
okay.
Thank you, sir.
Thank you.